everyone. Today we're looking at 4.2, which is solving trig expressions. Good news for us is that this is going to use a lot of content that we already learned, so this shouldn't be really a brand new topic for us. So what we're going to do is take expressions like we were looking at in 4.1 that had to be factored, they had trig in them, and now what we're going to do is there'll be equations. We're going to try and isolate the trig, okay? And we're going to set up problems like we had in 3.6, where we had to find the theta, where we had to work backwards. So the trig expression that I have here is sine. So I'm trying to get sine by itself. So I'm going to add 1 and divide by 2. Okay, so now I'm trying to solve sine of x equals 1/2. So sine is positive in quadrants 1 and 2. Okay, sine is opposite over hypotenuse. So my opposite side here is 1, my hypotenuse is 2, making this a 30, 60, 90, so my reference angle here is 30. Okay, so x can be 30, and x could be 150. So when we do these problems, we're only looking for the angles that are in between 0 and 360. Okay, so we do not have to write the solutions. So 30 and 150 are fine. All right, so if I have secant and I've got it on two sides of the equation, we need to get them together in order to solve. So a 3 secant minus a secant is a 2 secant. Right, so then add 4 and divide by 2. Alright, so secant is the reciprocal for cosine, okay, which means that the ratio here is hypotenuse over adjacent. So I'm going to turn that into a ratio by putting it over 1. And where is secant positive? So secant is positive wherever cosine is positive, which is 1 and 4. Remember, all students take calculus. Okay, so my hypotenuse is 2, and my adjacent side is 1. Again, making this 30, 60, 90. But my reference is now 60. Okay, so my angles are 60 and 300. Oh, now we've got some square roots. Okay, so I'm going to subtract 1. And I can just divide out that square root. Remember, we're just trying to get the trig alone. Okay, so I'm going to leave this with the radical on the bottom because remember, that's how we set up our special rights. Anytime that it had been rationalized, you had to undo that anyway. So cosine is going to be negative in 2 and 3. Okay, cosine is adjacent over hypotenuse. So my hypotenuse is root 2, and my adjacent is negative 1. Okay, so this is going to be a 45, 45, 90. So my reference here is 45. Okay, so figuring out those two angles, I've got 180 minus 45. So x is 135, and 180 plus 45, x is 225. Those are my two angles. Alright, so you could use a u substitution to factor this. We could say let u equal cosine of x. So u squared minus u. Now I have two factors here. So when I'm solving this, I have to split them both up. So cosine of x equals 0. Cosine of x minus 1 equals 0. So this is already solved. And this one is going to be cosine of x equals 1. Okay, so we're going to have to find our angle for each one of these expressions. So let's talk about cosine x equals 0 first. So being adjacent over hypotenuse, okay, in order to get 0 as a final expression, we would have to have 0 over 1 or 0 over negative 1. Now we can't use negative 1 because that would mean the hypotenuse is negative, and we know that's not possible. Okay, the adjacent side, there's no triangle that ever has the adjacent side of being 0, which means that this is possibly quadrantal. So let's look at our setup for quadrantal. So this is x over r. So where is my x value? 0. X equals 0 in two places, at 90 and 270. Okay, so my first set of answers over here. X equals 90, x equals 270. Okay, cosine x equals 1 is potentially going to give us 2 more. So we have a lot of possible answers for this. So again, cosine is adjacent over hypotenuse. I could have 1 over 1. I could have negative 1 over negative 1. But again, not possible because the hypotenuse cannot be a negative. Okay, well, no triangle has an adjacent side of 1, or I'm sorry, of a hypotenuse of 1. It does have an adjacent. So the hypotenuse of 1 is, what should tip us off here. This one also quadrantal. Now the hypotenuse is always 1, so that's not going to be the piece of information that we're looking for here. The fact that x equals 1 is what we want to identify. So x equals 1 only in one place. So x equals either 0 or 360. Either one of those. So you actually have 3, technically 4, I guess, angles here if we count 0 and 360 as their own separate answer. Okay, so when you factor and you get 2 separate expressions here, you have to split them up and solve each one. Let's try some more complicated ones. So again, this looks like it has to be factored, so you could use a u substitution if you wanted. Okay, u squared minus 1. This is going to be difference of squares. Right, and again, I have 2 separate problems to solve here. So cotangent of x equals -1. And I guess I skipped a step here. and cotangent of x equals positive 1. We have to solve each independently. Okay, so cotangent is the reciprocal of tangent. So my ratio here is going to be adjacent over opposite. So negative 1 over 1, 1 over negative 1. Okay, can you have a special right triangle that has an adjacent and an opposite side of 1? Sure, it could be a 45, 45, 90. So cotangent is negative in 2 and 4. Negative 1 and 1 fits over here. 1 and negative 1 fits in the fourth quadrant. So that seems to be working. So my reference here is going to be 45. So my first set of answers, x equals 180 minus 45, and then 360 minus 45. Okay, so I get 135 and 315 from the first expression. All right, cotangent of x equals 1. So again, opposite over adjacent over opposite. Okay, it could be 1 over 1. It could be negative 1 over negative 1. So where is cotangent positive? It should be opposite of the setup we just had. So 1 and 3, we are positive. Okay. Opposite adjacent. Make sure that your signs fit appropriately. So again, this is a 45 reference. So x equals 45, and 180 plus 45 to give us that second angle, 225. Okay, so if I have a sine squared and a sine, okay, hopefully you're seeing that those are not like terms. It's like an x squared and an x, okay, which means you're going to want to bring all of those terms to the same side. And this is now going to be factored, okay, with big X. This is a trinomial. Okay, so your u substitution here is let u equal sine x. Okay, so two equations. Sine of x plus 2 equals 0. Sine of x minus 1 equals 0. Okay, so sine opposite over hypotenuse. So this ratio would have to be negative 2 over 1. Okay. Do you have a triangle that has a hypotenuse of 1 and an opposite side of negative 2? So the only time that the hypotenuse can equal 1 would be in a quadrantal. But for it to be a quadrantal, the opposite or the adjacent value would have to be positive 1, negative 1, or 0, not a negative 2. So sometimes we get an expression like sine x equals negative 2 that does not actually produce any angles. So this one is impossible. And it's okay, sometimes that happens. The other one, hopefully that will give us. Okay, so we'd have to use 1 over 1. We couldn't use negative 1 over negative 1. for this whole hypotenuse business. Okay, but no triangle has a hypotenuse of 1, which means that this is quadrantal. And this is y over r. So again, r always equals 1. So the only unique information here is y equaling 1. So where does y equal 1? That only happens in one place. So x equals 90. So that is the only solution that we have to this problem. Alright, I definitely think I'm going to use my u substitution here. So I'm going to let u equal cosecant, and I'm going to let w equal secant. So I get uw squared minus 4u. So I'm going to take out a u. And then what I have left in parentheses happens to be a difference of squares. I have 3 factors here that I have to solve. So cosecant of x equals 0. Secant of x minus 2 equals 0. And secant of x plus 2. Alright, so cosecant is the reciprocal of sine, making this hypotenuse over opposite. Okay, well, the only way to get a 0 as my final answer would be 0 over 1 or 0 over negative 1. And the hypotenuse can never equal 0, whether it's a special right or it's a quadrantal. So this first one, impossible. Does not give me any values. Okay, secant is the reciprocal of cosine. So this is hypotenuse over adjacent. So I could have a ratio of 2 over 1. Well, do I have a triangle that has a hypotenuse of 2? Okay, so where is secant positive? Anywhere that cosine is. 1 and 4. So a hypotenuse of 2. Sorry, this is a little squished. And let me change the color here. Adjacent of 1. Okay, that makes this missing side a root 3 and a negative root 3. Okay, so my angle, my reference angle here has to be 60. Alright, so this one, we'll go over here. X has to equal 60 and 300. Alright, for the last one, so secant negative would be in the opposite quadrants of where we just had it. Okay, and so this hypotenuse over adjacent would have to be 2 over negative 1, because my hypotenuse always has to be positive. Okay, so this is again a reference of 60. Alright, but my angles are 120 and 240. Alright, very last one. Okay, so we're going to isolate our trig by dividing by 2. So I get sine squared x equals 1/2. So we could rewrite this, okay, which perhaps makes it a little bit more obvious that we have to take the square root of both sides in order to solve this. So square root of that does actually equal sine of x. Now be careful on the opposite side. When you take the square root, you need plus or minus. Okay, and square root of 1/2 is 1 over root 2. So this is giving you two solutions. Sine of x equals 1 over root 2, and sine of x equals negative 1 over root 2. Make sure you have both options because they're going to produce multiple answers, and you have to have all of those angles that satisfy this. So sine being opposite over hypotenuse, this first we're looking for our positive quadrants. Okay, a hypotenuse of root 2 is going to be a 45, 45, 90. So my reference here is 45, which makes this 45, and 180 minus 45, 135. Okay, we've already got a lot of the information figured out for us for the second one. Okay, sine is negative in quadrants 3 and 4. The opposite hypotenuse. So then the 1 has to be the negative, because this always needs to be positive. Okay, again, reference 45. So 180 plus 45 in this case is 225, and 360 minus 45, 315. Okay, so all of those are your solutions. So again, the key point here is make sure that you take plus or minus when you're square rooting it. Okay, now that we've solved all of these by hand, okay, meaning finding the theta by hand, I want you to go back and look at the complete trig chart that is posted in Classroom. Okay, from here on out, you will be able to use that chart instead of having to solve these problems by hand, meaning all of this work over here, where you have to use all students take calculus, you will be able to look up, 1 over root 2 in the chart in the sine row and follow it up